Hello again. Okay. These are going to be. This next video is going to be the proofs of your arithmetic and geometric series. One more time. This is going to be stuff for honor students, and especially for honor students for next year. It's good to be good at proofs, and I'm going to tell you a really fast reason why. You're going to understand your formulas a whole lot better if you know your proofs. If you don't know your proofs, God, it's you're really going to rely on your memory then on how to use a formula, and that's when it's going to get tough. Okay, because if you just rely on your memory, you're going to get it wrong. But understanding is forever. So if you understand what's going on, you guys should be fine. Okay, so I'm going to try to make this as interesting as possible. I like proofs. I think that they work really well and they help me understand math very well. And if you want to understand math very well, then this is something you want to listen to. Otherwise, go get the formula sheet and you can start the problems. Okay. So first of all, what I'm going to do is I'm going to write down my arithmetic series. Okay, and it looks going to look something like this. Remember, series is you're adding a bunch of terms together, and that's what I've got right now. Okay. So in this series, though, what I am going to do is I'm going to be adding a couple things. First and foremost, this basically means it's kind of, I'll call it continuance. It just basically continues a sequence. You can use your imagination as and find out that there's a T5, a T6, a T to the 27th in here, however long the sequence can be. All right, this over here I'll call my second last term because it's just right next to Tn. This is my second last term, and then this here at the very end here, this is my last term. Okay, so if you understand what each one of these terms are, that's fine. And of course, you should know what this one is here. This is your first term, and so forth and so on. Like you should know what these are. Okay, so let's keep going here. Um, I want to find a formula for this. I want to condense this to something that's usable, pliable when it comes to using it in a problem, and having to keep adding terms together just to find a series, it sucks. Okay, especially if you have so many terms, it's not going to work out. So what I want to do is I want to find something that's in common between some of these terms. Like there's got to be something in common between T2 and T1, right? And there's got to be something in common between T3 and T2 and T4 and T3 and so forth and so on. I can rewrite this series as such that it's going to be easier to understand. I can see the relationships, okay? Nothing's going to change when I write this, when I say that I have a T1 there. But I'm going to rewrite T2 as T1 plus D. Now, why is that true? Okay, and you're probably thinking, well, that is true because to get T2 from T1, I basically have to do what? I basically have to add D, right? I basically have to add D, and when I add D, I'm going to end up with this sum. Because this is what T2 is really, isn't it? Okay, let's keep going. If I'm going to call T2 T1 plus D, I'm going to call T3 T1 plus 2D. All right, and notice I didn't just put T2 plus D. If I put a T2 here, I kind of multiply my problems out again. I want to restrict all my terms so that they're the same. Like notice I have a bunch of T1s here, and I'm slowly going to build a bunch of terms with the letter D in it. That actually helps a lot. So what I'm going to say right now is that my T3 is really this term right here, T1 plus 2D. Okay, and then I can keep going. I can say that T4 is really T1 plus D added 3 times. Okay, because again, to get T3 I had to add another D, and to get T4 I had to have another D, and in this case I have 3 Ds, as you can tell, so that's why I have a third D right there. Okay, and so forth and so on. Now, I'm going to keep going here. I'm going to go plus, dot, 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 plus, and my second last term is going to be the following. Okay, I'm going to write it as so, and you're going to ask yourself, why does that make sense? Why is it that this second last term, draw it right here, equals that? Well, I'll tell you. Because, again, we know that to get from Tn minus 1 to Tn, I have to add D, right? One more time. To get from Tn minus 1 to Tn, I have to add D. Well, shouldn't I, to go from Tn to Tn minus 1, shouldn't I have to subtract D? Well, that's what that is right here. Okay? To get Tn minus 1, a representation for Tn minus 1, I could take Tn and subtract D. I'll end up with Tn minus D. And finally, I'm just going to finish this series off. I'm going to write Tn right here. So I've done a pretty good job. I've listed all my terms, and most of them have something in common, which is great. Okay, so there is something that you guys gotta understand though. You're thinking, man, you really haven't helped me out, Cito, at all. This is pretty tough. What do I do next? Well, we're gonna have to start relying on our simple operators here. Like the question I want to ask myself is, what happens if I were to add another series to this series? Okay, because if I'm able to eliminate some of these letters, I can figure something out. So I'm going to add a simple operator here. I'm going to just add SN. You know, so I'm going to add essentially what I have as a sentence here to itself. Watch what happens when I do. I'm just rewriting what I've got right here. And I want you to ask yourself here at home, why would this work or not work? Did I make things easier? Well, let's take a look what happened here. I took my series, my S of n, and I added it to itself. And when I did, I got this. I'm just going to skip it and make it easier here. Is that a good thing or a bad thing that I just did? Did it make life easier? The answer is, it sure didn't. Okay, I've still got numbers that are letters that are the same. I didn't cancel anything out. It sucks. And you know, that's the thing about proofs. You can't cancel stuff out. Kind of on the wrong track. Alright. But the thing about sums is that they're almost reversible. Because what I'm going to do next, and you might be able to see that, man, I should have done this in the first place. Maybe this will make sense. I'm going to rewrite my sum. And you know what? I'm going to rewrite it backwards. So it's going to look like this. I'm going to have a Tn right here. Okay, that's my last term. I'm going to write it first. I'm going to write this other term, Tn minus d. My second last term, I'm going to write it next. Okay, and I'm going to write the other term that was before that, the third last term. I'll write it as Tn minus 2d. Okay, and so forth and so on. And this one, if I were to add the fourth last term, it would have been Tn minus 3d, and so forth and so on. And then here, I'm going to add the term that was here in the first place. I'm going to have T1 plus d, and I'm going to add T1. All right, now, after looking at this, I'll let you peruse it and stare at it for a few seconds. Did we do a good thing? Did we do a good thing here? What did we end up canceling out? Well, I know that if I add these two together, I'm going to get 2s, and there's actually two series there, right? Okay, and my first pod here, this will add up. This sum will be T1 plus Tn. All right? What happens when I add these two terms together, the ones that are on top of one another? Well, I know my T1 and my Tn will sum, but this d and this negative d, what happens to it? Well, I'll tell you, don't these d's kind of disappear? They do, don't they? And I end up with another pod of T1 plus Tn. Okay? See this 2d and this negative 2d? These guys, when you add them together, they're also going to disappear too. So I end up with another proof. It's going to be T1 plus Tn. Okay? Or another proof, another pod. Okay? And I'm going to have another pod right here. These guys cancel out. I end up with T1 plus Tn. Okay, so forth and so on. I'll add my, I'm going straight to the end of my sequence. This negative d and this d will cancel out. Okay, so these guys are gone. I end up with T1 plus Tn. And of course, my final terms also add up. So, you know what? In a proof, when you have something that was vastly different, but they now are repeating, here, you did a good thing. You really did. But I have so many T1 plus Tn's here. I mean, how many of these terms do I have? Well, think about it for a minute, and then you'll see. Truth be told, you see this T1 here and this Tn here basically had about n steps, right? So really what I have here are n times. That's the number of terms I have. So if I were to write this thing, it would look something like this, where 2Sn equals, there's n times these pods. Okay. Now you're probably thinking, man, Cito, you didn't help me out any. I'm still confused. I don't know how to isolate Sn, my series. Well, I'll just do this magical trick, and here you go. This is your formula. N T1 plus Tn over 2. Okay, and this is going to be your arithmetic sum. The arithmetic sum right there, where T1 is your first term, Tn is your last term, and of course Sn is your sum. Okay, so this is your formula for your arithmetic series. Let's put a box around it so you can see it. Okay, and this is a proof. And I think now, once you've seen it, it kind of makes more sense here. There is an English way to understand it. Is that S of n? There's another way you could write it. Would be the number of terms times the average of your first and last terms. And if you can see that from the formula above, that's great. I'm sorry you couldn't see that. Let me write this down a bit. There you go. That's what I meant. Okay? So one more time. There is a way to write it in English, as you can tell right now, where your series is going to be n, the number of terms you have, multiplied by the average, which is your first and last term divided by 2. So this is also another way to remember it. This is kind of how I remember it. All right? You know, that's how my mind works. But this is something that you can understand how we got it. If you understand how we did all this, you know, you're in really good shape, and I'm very proud of you. Okay, so let's move on to the next step here. I'm going to do a formula for geometric series. Okay, so this is the fourth formula we're going to do right now together. Okay, it's a formula for your geometric series. Okay, and what we're going to do is we will do the same thing. That is, add backwards. Okay. Well, we'll actually subtract backwards, but you'll see what I mean in a minute. Add backwards, except we multiply by the common ratio r. So, for instance, right here, I'm going to write down my series right now. I mean, my series is going to be what? It's still the same notation. There's no real changes here. Okay. I mean, my series, even though it's geometric, still follows these same rules. I'm still going to have a T1 added to a T2, added to a T3, added to, and it's going to keep going until my second last term and my very last term, okay? And if you want me to label some of these again, I have some sort of continuance going on in here. Okay, continuance. I have a second last term right here. Okay, and I also have a last term right here. Okay, I've got a last term. And of course, if you want to spot my first term was here all along. Okay, so pretty good, all right? And let's rewrite this thing. I mean, all my terms are different. It's got different notations. There's a subscripts. There's a different subscripts. It's got a 1 here, a 2 here, a 3 here. Not cool. Can't really work with it yet. Let's see if I can rewrite this thing, okay, so that I can actually understand it. And I'll have to understand that S of n is really, I'll take my first term, okay, but I'm adding the first term again times r. Now, for those of you guys who kind of forgot how I got that, well, T2 is really, for a geometric series, or a geometric sequence, the case may be, T2 is really my first term multiplied by r, isn't it? It's multiplied by r. And then to get my third term is really taking the second term and multiplying by r again. So what's going to happen is that as I keep going, this is my second term, by the way, right here. My third term is going to look something like this. I'm going to take my third term. I'm going to have my first term, T1. I'm going to be basically multiplying r twice, and so forth and so on. Okay, so I'll add my continuance. This last part right here, as you can tell, you can see the number of r's I have is 1 less than my subscript. So here I had 1 r. Here I had 2 r's. So basically here I'm going to have T1 times r n minus 2, because again I have 1 less than my subscript. The exponent on top of my r is 1 less than the subscript that's in my sequence right here. Okay, and finally here, this last one will be T1 r n minus 1. For those of you who forgot how I got my last term, look at proof number 2. This is essentially the my last term. Okay, now what I'm going to do next is the following. I'm actually going to